Let's take a look at another application. Let's read through this. One evening, 1,600 concert tickets were sold for the Fairmont Summer Jazz Festival. Tickets cost $20 for covered pavilion seats and $10 for lawn seats. Total receipts were $20,000. How many tickets of each type were sold? So again, we need to look through and say, how many unknowns do we have here? How many tickets of each type were sold? What type of tickets were discussed? Covered pavilion seats and lawn seats. So we want to know how many pavilion seats and how many lawn seats were sold. So we might begin to keep up with our information by the type of tickets. So we could say one type was pavilion tickets and one type was lawn tickets, and then we know we're going to have a total number of tickets. So we're interested in the amount of tickets, or the number of those tickets sold. And since the question says how many of each type were sold, we know that we're going to be looking for the number of these tickets. So how about we let the variable x stand for the number of pavilion tickets, y stand for the number of lawn tickets. Were we given the total number of tickets? One evening, 1,600 concert tickets were sold, so we do know the total. Alright. Now what other kind of information are we given here? We're given the cost of these tickets, $20, so let's put the cost here. And the cost was $20 for covered pavilion seats, so we'll put 20 here for pavilion. $10 for lawn seats, so we know that this is $10. And total receipts were $20,000. Okay, now we don't have a cost per total ticket here, so we need another column to extend. So we could say receipts for each kind of ticket and total tickets. So pavilion tickets, how much money was collected for those or received for those? Well, it's the number of tickets times the cost of a ticket. So we could say 20x. How about the lawn tickets? The number of tickets times $10, or 10y. And then we do have total receipts. Okay, we were told in the problem here that total receipts, $20,000. All right. Now we should have now two equations come from this information here. Do the two kinds of tickets added together give us the total number of tickets sold? Yes. So equation 1 is x plus y is equal to 1,600. Do the receipts for one type and the receipts for the other type give us the total receipts? Yes, they do. So there's our other equation. 20x plus 10y is equal to $20,000. 20x plus 10y is equal to 20,000. Alright, now we have two equations and we can work with them to solve a system of two equations in two variables. So it looks like maybe a good idea to try to eliminate y if I could multiply to get a negative 10y. So I'm going to put this in parentheses to show that I'm going to multiply equation 1 by negative 10 and rewrite it here with that multiplication carried out. Negative 10x, negative 10y equal to negative 16,000. Okay. Now I'm going to rewrite equation 2 with no change made because it will cancel the y terms here. 20x plus 10y is equal to 20,000. And we're adding here to eliminate the y's. And now we can total the x column for 10x and total the constant column for 4,000. We can divide both sides by 10 and give us x equal 400. Okay, 400 is the number of tickets for the x variable, and we said that that was pavilion tickets. So 400 equal the number of pavilion tickets. Remember, we also need to find the number of lawn tickets, which is the variable y. So we should be able to take the amount 400 for x and substitute that into the easiest looking equation of the two, which I believe is 1. So let's rewrite equation 1, x plus y is equal to 1600, and replace x with 400. 400 plus y is equal to 1600. Let's subtract 400 from both sides, and that gives us y is equal to 1200. Okay, now remember, the easy check for this is to say, do our x and y values add for 1600? It says 400 plus 1200. Yes, that adds for 1600. Now remember, we would need to put those numbers into equation 2 and check also that 20 times 400 plus 10 times 1200 really does equal 20,000. Okay, be sure to run your check on those.